Hello and good evening, CSI258 Section 847 students for the second 8-week term at Anne Arundel Community College for CSI 258, which is Networking 4, the final of 4 courses in the Cisco Networking Academy curriculum, Connecting Networks. This evening's PacketTracer tutorial is going to be on PacketTracer Activity 3.1.2.7, where we're going to take a look at troubleshooting serial interfaces. So we're going to diagnose and repair the physical layer, the data link layer, and the network layer. So the scenario is we've been asked to troubleshoot some connections for a local telephone company. The telco router should communicate with the 4 remote sites, but none of them are working. Use your knowledge of the OSI model and a few general rules to identify and repair the network errors. So let's jump right in here. Step 1, diagnose and repair the cabling. Examine the addressing table to determine the location of the DCE connections. And so as you can see here, remember the DCE is the data communications equipment. And 9 times out of 10, the data communications equipment is going to commonly be a CSU, DSU. It could actually be built onto the Cisco HWIC card. And 99% of the time, the DCE end is going to be at the telco end of the connection. So let's go ahead and pull up the telco router here and give ourselves a little more viewing space. And let's go ahead and dive in and see what may be the issue. So we're on the telco router here, excuse me, and let's go from user exec to privilege exec, and let's type in the show controllers command, and then it says it wants to take a look at the interface. So we'll do serial 000 first, and let's see the output that we have here. So you can see that we've got the DC end of the cable. It's a V35 connector, right? And the clock rate is, and this is in bits per second. Now this is interesting here because this is 2 million bits, so it's 2 megabits a second. And oftentimes learners will look at this and become a little confused as to whether or not this is a T1 card because the speed goes up to 2 megabits a second. Well, it just so happens that if we look over here, I've got a convenient link here from the Cisco website that talks about the HWIC1T, the HWIC1DSU, HWIC2T, and the speeds that those cards can go up to, or at least the clock rate that they can be increased to. And so we're going to take a look under this interface here, and you'll see that we may be able to increase this to 8 million bits per second, which would be 8 megabits per second. In fact, I have a router here, and this is an actual physical Cisco 1841 router that does have the HWIC1T card in it. So if I were to say show controllers, whoops, do show controllers serial 010, you can see that, well, we've got the DTE side here, so R4, which is connected directly to it with a back-to-back serial connection. This is my DCE side, so you can see here we've got the exact same output, and the clock rate is 2 million because this card, the HWIC1T, can support a T1, and it can also support an E1, which is 2.0, I believe it's 48 megabits per second. So if I were to go into the interface, so I'll do a type conf T to get into global config, and then I'm going to say interface serial 010. If I type clock rate and a question mark, you can see the bits per second that are supported by this HWIC1T. And as you can see here, it maxes out at 8 megabits per second, and sure enough, that matches the specification in the Cisco documentation. I have a couple of these on order, the HWIC1 DSU T1s, and I'll get those inserted for a future tutorial, and we'll be able to take a look at those and see that they're going to max out at 1,544,000 or 1,536,000 right here. So that's a quick look at why we see the clock rate in there. And the clock rate is also going to be, you'll see it in the interface as well. So if I were to say show, well actually we have to do a full show run here. So I'll do a show run, and you'll notice that the clock rate shows up under the interface. And so we've got the clock rate here of 2 million, and in our troubleshooting that may become an issue, so we'll have to look into that. But you can see that the clock rate gets set on the telco side. That way the telco can actually manage and sort of be a governor for the speed of the link, because this is going to dictate the actual speed at which this interface transfers data. I apologize, I'm coming down with a cold here. Excuse me. All right, so that's a quick look at the telco router. So let's see what it wants us to look at. It says determine if each telco interface is using the correct end of the cable. Look at the third line of output. So let's go ahead and see here. So if I were to say show controllers, and we're going to look at serial 000, which we just did, and so that's a DCE, so that's correct. Let's take a look at serial 001. That is also a DCE. The clock rate might be a little high. We'll check into that in a second. 010, and this is also a DCE. And then finally 011, and we've got a DTE here on 011 that interfaces with router 4. So it looks like there's a DTE interface here, and let's do a show run, and let's check out serial 011. So as you can see there, the clock rate is set, although the side says DTE on the telco side connected to R4. All right, so it says reverse any cables that are incorrectly connected. So we definitely want to go ahead, and we're going to select this cable here, and actually we just want to get rid of that guy. Sorry about that. I'm going to get rid of that cable, and we're going to come down here to the connections area, and I'm going to look for the DCE cable. So we'll hook it in here to serial 011, and this goes to serial 001. And so now let's take a look here and see the interface went down and up as we replaced our cables. So if I do a show controllers on serial 0/1/1, you can see now that we are the DCE side of the cable, and interestingly enough, I believe the clock rate was 4 million. Is that right? No, it was 2 million. Okay, so the clock rate didn't change. So, but we have the DCE side correct. All right, it says in real network settings, the DCE, which sets the clock rate, is typically the CSU/DSU. And that was from my comment earlier. All right, so diagnose and repair incorrect port connections. So it says examine the addressing table to match each router port with the connect telco port. Hold the mouse over each wire to ensure the wires are connected as specified. So let's hold here. So router 1. Let's see if we can get it to show. I'm mousing over. It doesn't want to cooperate here. So let's pull back up router 1 and let's make sure, or I'm sorry, telco. Pull the telco router up here and let's take a look. So we can see that serial 000 has the correct address, 64.134.17. Serial 001 also has the correct address, .21. We've got 34.25, which is correct. And we've got 34.29, which is correct. So let's go ahead and take a look at routers 1, 2, 3, and 4. Let's enlarge this a little bit here. We'll go to the CLI, go to privilege exec mode, where we'll say show controllers, and we'll look at serial 000, and this is the DTE side, and you can see where it says clocks detected. It's detected the clocks on the opposite side. So we'll do a show run to take a look at that interface to make sure that that interface has the correct IP address. And so what we see here is our diagram is showing us that this is .18 and this is .17. However, on router 1, the IP address appears to be the same IP address that's configured on the telco router for the same interface, 64.134.17. and 64.134.17. So let's go ahead and correct that. So we're going to go into global config with config T, and then into interface serial 000, where I'm simply going to overwrite that IP address statement by saying IP address 64.100.34.18, and it's a /30, so a 252. All right, so now if I were to say do ping 64.100.34.17, all right, so we've got connectivity there. So it looks like we've got one of the issues that was wrong. Let's take a look at router 2. Or I should say the second issue that was wrong. First issue was the cable between the telco router and router 4. And let's bring this up just a little bit here. All right, let's see what we've got here. So we're on router 2, we're going to go from user exec to privilege exec, and we're going to do a show run and take a look at what we've got here. So router 2 should be using serial 001. It is. The IP address is correct. And interestingly enough, we have a clock rate statement here. Let's go back to router 1. Did we have a clock rate statement? We did, but we didn't here. So serial 001 on router 1, right? This, if we check, if I say do show controllers, and we look at serial 001, it says no serial cable attached. So right now it's going to think that it is the DCE end of the connection, and that's why the iOS automatically drops this clock rate command in here for you, giving you the maximum speed for the type of card that you have in there. And so now let's take a look here. We've got no clock statement, right? Because that is the DTE side, right? The data terminal equipment side, which you would have at your local site. So we don't need the clock rate command there. Let's take a look at the telco router. So I'm on router 2 here. We've got a clock rate statement. Let's take a look at the telco router, and the interface to serial, or to router 2, I should say, is serial 0001. So take a look here. So we have mismatching clock rates, right? And the clock rate should be set on the DCE side, the data communications equipment side. That's the telco side of the house, because that's where it's being controlled. So let's see if we can get in here. I'm going to go into global config mode, interface serial 001, and we're going to say no clock rate 2 million, which is 2 megabits a second, because we had mismatched clock rates on there. So we'll pull the clock rate off, and now let's do a do show run. Let's see if it allowed us to take that off. It does not. So what does that mean? That means that we are misconfigured on the telco side, and that was the reference I made earlier. So that clock rate command we can't take off. So let's go ahead and let's match the clock rate. So we're going to say, whoops, conf t. We're going to go into interface serial 001, and I'm going to say clock rate 2 million. And so now the clock rates match. So let's step back over here to router 1. You'll notice router 1 doesn't have the clock rate. We couldn't get it off of router 2, so router 2 still shows the clock rate 2 million. And now let's rerun that command. Let's see if we can take that clock rate off of there. And we might not be able to get that off of there, right? So it's put in there by default. But again, if I do a do show controllers, let me make sure this is the DCE side 001, or the DTE side, sorry about that. So it says no serial cable attached. And let me make sure, and let's actually, should probably take a look at the do show run, and hopefully this port is not shut down. And on router 2, serial 001 is definitely not shut down. Let me make sure it's not shut down on the telco side. Do show run. It didn't look like it. Serial 001 goes to router 2. Alright. And so it says no cable attached. So let me go ahead. I'm going to pop this cable off of here, and let's get a new cable. I'm going to grab a DCE cable, and this would be serial 001 to serial 001, and let's see if that was, maybe there was something wrong with the cable, because on the DCE side, or I'm sorry, the DTE, as in T as in Tom, on the terminal, data terminal equipment on the office side, or the branch side, you should not see that clock rate to show run. And let's see. All right, there we go. Much better. So the clock rate was off because, again, when on the DCE, if it thinks it's the DCE side and the clock rate command is there, and it is, or if it is the DCE side, the data communications equipment side, you will not get that clock command off of there. All right, so we've got the cable swapped out. Let's see, do we have connectivity? How about do ping 64.100.34.21. All right, we've got connectivity. So let's check on router 3 in the telco router here. And one of the first things we'll check is to see if it says something's connected or not. So we're going to go from user exec to privilege exec, and I'm going to say show controllers. And this is going to be serial interface 000 on router 3. And let's see what it says here. It says it is the DTE side. The clocks have been detected. If I do a show IP interface brief, it looks like something's going to be down. So serial 000, it shows administratively down. So let's make sure, whoops, so we'll do a show run. And was it shut down? It is. So I'm going to go into global config mode. I'm going to go into the serial interface, and I'm going to say no shut. And the IP address 64.100.34.26 is correct. And the corresponding, and there we go, and it says change state to up. So let's do show IP interface brief. Now it shows that it changed to up, and here it is. So let's see, do we have connectivity? Do ping 64.100.34.25. All right, and we've got connectivity there. And so now let's go ahead and take a look here at router 4 and see if there's anything. I'm assuming we've got one issue per router. And we'll go over here to the CLI, go from user exec to privilege exec, do a show IP interface brief. Aha, so now this is an interesting one here. So it shows that the serial interface is at layer 1 it is up, but at layer 2 it's down. So let's do a show controllers on serial 00. Aha, and I think I see the issue. So according to the table here, router 4 should be serial 001 with the IP 64.100.34. Oh, I'm sorry. I went scooted right by it. It is. Thought it was transposed there. So, okay, so this is correct. So the interface shows is down. So let's see what the show controller shows. Shows it's the DTE side, so that's good. And the clocks have been detected. That's good. So let's go ahead and do a show run one more time. Okay, and the interface is not. Aha. So what do we see here that we have not seen on the other links? The other links have all had the default encapsulation of Hdl-C. The high-level data link, I'm drawing a complete blank right now. So high-level data link control, sorry. Well, the C at the end gave me some trouble there. So the high-level data link control. Now, a quick note on this, right? So Hdl-C, high-level data link control, is actually an international organization for standardization, ISO standard, right? Now, and this is sometimes confusing for new learners. So Hdl-C was a public open standard with ISO before Cisco adopted it and then kind of added their secret sauce to it. So if I go down a little bit here on the Wikipedia page, you can see that, and it mentions Cisco in here specifically, and here it is right here. So some vendors, such as Cisco, implemented protocols such as Cisco Hdl-C. So they basically took the ISO standard of Hdl-C, high-level data link control, and then sort of added Cisco's secret sauce to make it do what Cisco needed it to do. And really, the major difference is that they simply added in a 2-byte type field. And what that 2-byte type field allows Cisco to do is to support different layer 3 protocols. So IPv4, IPv6, AppleTalk, IPX. And that was really the extension that Cisco made, one of the major extension that they made to the ISO Hdl-C standard. Because when we start to talk about PPP, which we see in the encapsulation, for the encapsulation method here, PPP actually uses the original, very similar to what Cisco did. They use the framing from the standard, the ISO standard Hdl-C, and then they add in a protocol field as well as a field for padding, right? But PPP adds in the protocol field, and it also gives you far more functionality than Hdl-C does. So basically, in the course, we're going to talk about 2 different types of encapsulation. The first one is the default on Cisco hardware, which is Cisco Hdl-C. And very similar, right? When we had our conversation about spanning tree, this is very analogous to the conversation on spanning tree, where you had the 802.1d spanning tree protocol. Cisco said, hey, we're going to take that, we're going to add in our secret sauce, and guess what? You got the Cisco's per VLAN spanning tree, right? And then it was the same thing again when 802.1w came out, the rapid spanning tree protocol. So Cisco took the protocol, extended the protocol, adding in their secret sauce to customize it to do what they needed it to do. And then what did we get? We got per VLAN rapid spanning tree, right? So it's very similar here. Again, Cisco took the open ISO standard for Hdl-C, extended it by adding in a 2-byte type field to allow for multi-protocol, multi-layer 3 protocols, and that's C. And it's commonly, you'll see it sometimes referred to as C Hdl-C, and all the lowercase c represents is just Cisco Hdl-C. And again, PPP, same thing. PPP uses Hdl-C, and this is where new learners will become confused, is if you hear that, oh, well, PPP is using Hdl-C, make a quick mental note that when someone refers to it like that, they're not talking about Cisco's implementation of Hdl-C. They're talking about the ISO implementation of Hdl-C. And that's what PPP is using. That's also what Cisco's using. And then they both kind of customize it to do what they want it to do. All right, so that was a quick sidebar there. So, but really brought upon, the conversation really was brought up by the fact that we now see this encapsulation PPP. So if I were to say, show controllers here on serial 001, we would be able to take a look, and we should see that, and there's all kinds of stuff going on here, and I'm going to look right by it. And I can't do the include command in cap. I may have gone right by it, because there's generally a line in here that tells you what the encapsulation is, and I might not be in the right spot. So yeah, I'll come back to that. But there's usually, and I've drawn a blank on the command. Let me see if over here they give us any assistance at all. Show interface. And I think that may be it. Show interface serial 001. And whoops. So it doesn't show the in-cap PPP. So I'm kind of drawing a blank here. I know that, oh, I'm sorry. There it is. Yeah, it is show interfaces. All right. If you were screaming at the screen, I went right by it. So here's where it shows me my encapsulation is with the show interface command. So if we come over to the telco router, let's look at the corresponding link on the other side, which should be serial 011. So I'm going to say show interface serial 011. How about a do show interface serial 011? And I'm going to find it much quicker this time. There's our encapsulation is Hdl-C. So this is common if I do a do show IP interface brief. Remember, it's saying, hey, our layer 1 is up, right? The physical layer connectivity, the cabling, you're good. We've got connectivity. However, at layer 2, and that would be at the encapsulation layer, right? Layer 2, the data link layer, we've got an issue here with Hdl-C on one end and Ppp on the other end. So we've got two ways we can tackle this. We can either encap Ppp, set encapsulation to point-to-point protocol here on the telco side, or we could remove the encap Ppp from the R4 side. So I'm feeling a little adventurous here, so let's go into interface serial 011, and I'm going to say encap Ppp. And we should see that that line state changes to up. And I'm now going to do a do show IP interface brief. And it shows that we're in an up and up state. Now I noticed that the points did not increase there. So they were probably not feeling as adventurous as I was right there. So let's take the encap off there. And there may be a note in here somewhere stating that we need to have Hdl-C. Change the encapsulation type. All right. So when all else fails, read the instructions. So let's go back to router 4. We're going to go into global config mode, interface serial 001, and I'm going to say no encap Ppp. All right, and that's going to bring our interface up. Now if I do a do show IP interface brief, you can see that the interfaces are up and up. Okay, so we've got 100 out of 100. Let's test connectivity, do ping, and we are 64.100.34.29, I believe, on the other side. There we go. And before we break out here, a couple quick notes. So we took a look, right, at the history of Hdl-C. It was based here on IBM's SDLC protocol, which IBM was using. And then Cisco took it and they went ahead and added their own secret sauce in to come up with Cisco's implementation of Hdl-C, just like they did with Spanning Tree. And if we come back up here, if you take a look here, the point-to-point protocol, which we're going to get into more as we move along in these PacketTracer activities. So here is the point-to-point protocol RFC, which is very interesting read. And it's RFC 1661, and this is basically, it just provides a standard method for transporting multi-protocol datagrams over point-to-point links. It's comprised of 3 main components, and we are going to talk a lot about the link control protocol and the network control protocol, right? So this is a great read right here. It is not that long. And then 1662 is Ppp in Hdl-C-like framing. Right? So this document describes the use of Hdl-C-like framing. So this is the document that describes how Ppp is leveraging Hdl-C sort of under the covers, behind the scenes, in order to do its framing, right? And then it made some extensions to it, and we talked about one of those extensions, which was the protocol field, right? And then there was a padding field. And again, this is a very short RFC, but it goes into a lot of great detail as to how Ppp is using the Hdl-C type framing. And again, 1661 is the RFC for Ppp. And let's see if they have a mention here. I do believe, let me do a quick search here, and let's look for Hdl-C. Yeah, so, and there it is right there. So it's Hdl-C-like framing. So really they took the Hdl-C framing and added a whole bunch of new stuff in there. And what you'll find is with the Hdl-C framing, right, you get error detection like Ppp, but other than that, that's about it. What you don't get, right, and here are some of the significant differences between PPP and HDL-C. So PPP has link quality management, so you can actually set a quality statement in there that, you know, you set it to 80%, and so if 80% of the packets are not received, if more than 80% or more than 20% is dropped, then the connection is going to go down. You've got loop detection with the magic number. We're going to be taking a look at that when we do some debugs. You can do multi-link, right, which you can't do multiple serial links with HDL-C. But you can do it with PPP. There's no authentication with HDL-C, so HDL-C is kind of wide open. We can do PAP and CHAP as well as EAP and some other ones with PPP. And compression algorithms. You get one. You get the stacker compression algorithm with HDL-C, and that's it. With PPP, you get a whole host of compression algorithms that you can use. And then finally, and we actually already mentioned authentication, so then, like I said, you have authentication. All right, so that concludes this video tutorial on PacketTracer 3.1.2.7. Hopefully you know a little bit more about HDL-C and PPP as well as serial links than you did before watching. All right, thanks for watching and have a great evening.